welcome back to my channel. So today, guys, I want to solve a particular question that I saw online. So the question says, find the value of the following infinite sum. So we're having 1 plus 3 over pi plus 3 over pi over 2 plus 3 over pi over 3 up to pi over 5, right? So basically this is a series, right? This is a series. So for us to calculate, now this is an infinite sum. Basically we can't actually calculate the sum to infinity of a series because it's actually to infinity. It has no end. So we can't actually calculate the value when we sum it up to infinity. So basically we are going to check the kind of series we are given. So basically we have two types of series. We have the arithmetic or progression. Actually, we have the arithmetic progression and geometric progression, or arithmetic series or the geometric series. So we're going to check if this is an arithmetic series or a geometric series. So for us to check if it's an arithmetic series, you know that we have to divide we have to take the difference of the second term and the first term, or the third term and the second term, or so on and so forth. Now, when we take the difference of either of these scenarios, we are expected to have the same answer. So to check for AP, right, I'm going to check for AP, meaning I want to check if it is an arithmetic series, right? So I'm going to take the difference of the second term and the first term. So taking the difference of 3 over pi minus 1, meaning that first to check if it's an AP, the difference of the second term and the first term will be equal to the difference of the third term and the second term. So this actually has to be equal to 3 over pi over 2 minus 3 over pi. So now let's take the difference. So we'll be having pi in pi is 1 times 3 is 3, minus pi in 1 is pi, pi times 1 is pi. So this is what we're having on the left hand side. So now let's check what we have on the right hand side. So this is taking the LCM of this is pi over 2. Pi over 2 in pi over 2 is 1 times 3 is 3, minus pi over 2 in pi is pi times 3 is 3 pi. So you can see that this is not equal to this. So definitely this is not an arithmetic series. So they are not equal. So now let's check for GP. When I mean GP, I mean geometric progression or geometric series. So now let's check for GP. So for us to check if this is a geometric series, the second term divided by the first term should be equal to the first term divided by the second term, right? So the second term divided by the first term, that's 3 over pi divided by 1, should be equal to 3 over pi over 2 divided by 3 over pi. So this divided by this gives me 3 over pi, and this divided by this gives me times pi over 3. This and this is pi, so this is this. So I'm left with 1 over pi. So you see that they are not actually equal, right? So now let's check, because this is definitely not an arithmetic series, but it can be a geometric series. So now since we have checked for this condition, now let's check if the second term divided by the first term can be equal to this divided by this. So we'll be having 3 over pi over 2 divided by 3 over pi will be equal to 3 over pi over 3 divided by 3 over pi over 2. Right? So now this divided by this actually will give me what? So this times pi over 3, right? Pi in pi is pi cancel pi, that's remaining pi. This cancel this, that's 1 over pi. This divided by this times pi over 2 divided by 3, right? This in this, I'm left with only 1. So this is, so you see that they gave me equal answer, right? So meaning that, so taking this divided by this and this divided by this gives me the same answer, and this divided by this divided by this will give me also the same answer. So definitely starting from this point to infinity, it becomes a geometric series, but it does not satisfy the first term, right? So the first term here we are given is 1. So, and when we did this divided by this and this divided by this, the answer we got was not equal. So that means geometric series started from this point down to infinity. So we're going to be calculating the sum to infinity, starting from this point to infinity, then adding it to 1. It's very easy as that, because we're actually looking for the values of the following infinite sum. Meaning, when I sum it up, what am I going to have? When I sum it up to infinity, what is the value I'm going to have? So, and definitely starting from this point, calculating the sum from this point to infinity is a geometric series, right? From this point to infinity is a geometric series. So I can calculate the sum to infinity of a geometric series. Then the answer I get, I'll just simply add it to 1. So now let's calculate that. So sum to infinity from this to infinity, right? So the first term we're going to be using here is 3 over pi. So my first term is 3 over pi. My first term here is 3 over pi, right? Now, my common ratio, right? So, my common ratio, starting from this point down to infinity, we've seen that to calculate my common ratio, we all know that is this divided by this, or this divided by this, right? So, this divided by this, we calculated it here to be 1 over pi, right? So, my common ratio, RO, is 1 over pi. Right? Then that's all what we need, right? So to calculate the sum to infinity, starting from this point down to infinity, what is sum to infinity? Meaning that when I add this and this and this and this, getting to infinity, I'm supposed to have a certain value, right? I know that sounds impossible, but we can actually calculate it. So the formula for calculating this, the sum to infinity of a geometric series, is represented as s to infinity is equal to a divided by 1 minus r. So this is the formula for calculating the sum to infinity of a geometric series. So since we have gotten our parameters here, this and this, right? Just simply put it here. So my s to infinity is equal to my first term, which is 3 over pi, divided by 1 minus my r, which is what, 1 over pi. Right? So this becomes equal to 3 over pi divided by 1 minus 1 over pi. This gives me pi minus 1, right? So we can divide this all through, right? We can divide this. So this gives me 3 over pi divided by pi minus 1 over pi. So certainly this gives me 3 over pi times pi over pi minus 1. Pi cancels out pi, so I'm left with 3 over pi minus 1. So the sum to infinity of that geometric series is 3 over pi minus 1, meaning that this is the value when I add up. Now this is the value when I add up 3 over pi down to infinity. When I add up, starting from 3 over pi plus this plus this plus this plus this down to infinity, the value I'm going to have is 3 divided by pi minus 1. I've calculated the value when I sum this down to infinity, right? I sum this whole series up down to infinity, and I had a certain value, which is 3 over pi minus, that's 3 divided by pi minus 1. So now all I need to do now, since I calculated this down to infinity, is to add my answer plus 1. So the value when I sum this to infinity will be equal to 1 plus s infinity, right? So the value when I sum this down to infinity will be 1 plus the answer I get for summing this up. So, and the answer I got for summing this up was 1 plus 3 divided by pi minus 1, right? So 1 plus 3 divided by pi minus 1, we are going to take the LCM, which is pi minus 1, right? Pi in this is pi minus 1 plus pi minus 1 is 1 times 3 is 3. So we'll be having pi minus 1 plus 3 divided by pi minus 1. So minus 1 plus 3, that is pi plus 2 divided by pi minus 1. So when I sum this When I sum this up, 1 plus this plus this plus this down to infinity, the value I'm going to get is pi plus 2 divided by pi minus 1. So thank you guys for watching, and please hit the like button or hit the subscribe button, and make sure you drop a comment if you understand. Thank you very much for watching.